Hi, this is Lab 4 bar magnet with Hudson Groover. So in Lab 4 we demonstrated the principles of Blot-Savart's law and permanent bar magnets to measure the field of a bar magnet using a manometer, which we use to measure magnetic fields. So this is the expression where R and U are parallel or anti-parallel or perpendicular. It's more accurate from afar, not as accurate from a distance, and hard to hand calculate, so we use computations. And our system is a bar magnet and the phone measuring. So assumptions: closed system, no interference with the earth field, so we make it perpendicular, and no interference with electrons and other fields. So there's two different setups, with the phone perpendicular to the bar magnet and the phone perpendicular and offset on the y-axis. And we use the manometer on the phone to measure the strength of field and report it on an Excel sheet and perpendicular with earth field. So this is the data, and then calculations for our simulation: use intercept graph, intercept equals 14, magnitude magnetic moment, and this is our code with our dipole and our different vectors, which are offset distance and negative distance, and then we create each of our arrows using the different positions and axes, and if they're perpendicular or not, and our B scale make sure the arrows is all correct, and we use the magnitude and the magnetic moment and insert that data in, as well as the D perp. And so this is what our simulation resulted in. Possible errors: the simulation may have been off a little bit because it's not using like tons of significant numbers, and distance was measured by hand with the phone and the manometer, and it was measured with the phone. So what if you hadn't oriented? The magnetic field from the Earth would have interfered with the results, either stronger or less, depending on the orientation. And what if you were to stick to identical? It could increase the strength if in the same orientation and weaker if opposite.